Hi everyone, welcome and thank you so much for joining our webinar today. My name is Corey Brickman, Marketing Programs Manager here at Neo4j, and I am thrilled to welcome you to this webinar featuring TruSTAR. Our presenter today will be Shimon Modi, Director of Product over at TruSTAR Technology, as well as Ian Sinnott, Senior Software Engineer over at TruSTAR. We also have Stefan Kolmar, our Director of Field Engineering here at Neo, to give you a quick introduction and answer any technical questions you might have. So with that, I'll give a few housekeeping notes. All attendees are in listen-only mode, so if you have any questions, we are happy to take those at the end of today's presentation. You can submit those right in that questions box in your GoToWebinar control panel on the right-hand side of your screen. We'll also be recording today's presentation and sending that to you via email along with the slides, so you will receive those tomorrow via email. And with that, I will go ahead and hand it right over to Stefan.
Thank you, Corey. Hello, good morning, good afternoon, or good evening, wherever you are, and welcome to today's webinar on TruSTAR presenting the Incident Exchange Platform to support security operators. My name is Stefan Kolmar from Neo Technology Field Engineering, and I will briefly introduce the main presenters of today's webinar, kick off with an intro of Neo4j as the leading graph database, and then hand over to Ian and Shimon. Ian leads the UI/UX team at TruSTAR and is a passionate professional empowering users through intuitive access to data. Shimon is the Director of Product and Technology at TruSTAR Technology and experienced senior expert in cybersecurity. Let's start first with a very quick graph database intro. So what is a graph? In a sense, in this context, it is a way to represent data. Over the last decades, corporates have established relational databases to manage their data. While on one side, this is good for building applications on top of static structures, it inherits an abstraction from the reality by using techniques such as entity relationship models, often establishing the need for predefining access to the data in order to achieve response times required, and sometimes lacks flexibility for changing requirements or additional connections within the data or data growing, etc. On the other hand, graph databases are allowing to take advantage of connected data and are providing the flexibility needed to support dynamic systems. Neo4j, as the world's leading graph database, is adopted in nearly all verticals, from finance to retail and telco, to media, software, social networks, and security. Large installations at industry leaders are proof points that graph databases are mature to handle your data and provide a leading edge going forward and develop competitive advantages. By adopting Neo4j as a corporate, you can reimagine your data as a graph. You can model and store your data as a graph, taking advantage of all connections within the data, traversing in real time, and providing response times needed for business-critical decisions. Your applications seamlessly evolves to support new requirements by adding new kinds of data and relationships. Various benefits will be inherited by using the right tool for the job. You can provide new, unique functionality, taking advantage of all connections within the data, find and show new insights into data. The user will benefit from faster application performance and a better user experience. By using a data model which is intuitive and understood by IT and business stakeholders, the overall complexity decreases and the software is easier to maintain. Overall, we see projects being faster adopted with lower costs, ensuring successful deployments. Talking about databases naturally always raises the questions of performance. One of the main advantages of using Neo4j is the ability to traverse the graph and follow connections in lightning speed. While in a relational database, you often need a join to materialize a connection between two entities, in a graph database, you just follow the connection, which leads to finding, as an example, friends of friends of friends, and so on, being an extremely fast traversal in a graph independent of the size of the data set, compared to the need to a self-join in a relational table with all the inherited costs and complexity. In summary, Neo4j provides high business value to support the needs of today's requirements such as the ever-increasing data volumes and the fact that these increased volumes are highly connected and can be unused to unlock value. On the right-hand side, you see a couple of example areas where Neo4j can provide significant value, ranging from real-time recommendations, such as if you are interested in graphs, I would highly recommend ImageBook, to detecting fraud by being able to understand if and how fraudsters are connected, to graph-based search by being able to relate search expressions with their semantic context, so that if somebody is searching for cybersecurity, the search engine knows that TruSTAR plays in this area, and therefore TruSTAR would be a valid search result. Not surprising, early adopters of graph technology became industry leaders and are more agile and more successful than other companies active in the same industry. I hope this provided some context for the webinar upcoming and raised some interest to look deeper into Neo4j. With that, I would like to hand over to Ian and Shimon. Shimon, the floor is yours.
Great, thank you. We're going to switch over to our screen here.
Excellent. Well, good morning, good afternoon, and good evening, everyone. Thank you for joining this webinar. This is Shimon Modi, the Director of Product at TruSTAR, speaking. And I would like to thank Neo4j for inviting us to present at this webinar. And as Corey and Stefan said, we'll be taking questions at the end. The purpose of this webinar today is we want to talk about how TruSTAR is using graph databases for modeling and visualizing cybersecurity data. And I'll be going into some of the details around what makes cybersecurity data a good fit for graph databases. But before I go into the technical nitty-gritties, let me just start by quickly introducing what we do at TruSTAR. We are an early stage startup, cybersecurity startup, and we are building an anonymous security incident exchange and collaboration platform for security operators. If nothing else, just try and keep these two words in mind as I go through the rest of the presentation about the value that we are trying to provide, which is around making incident exchange easier and making collaboration easier. So the agenda for today's presentation, I already talked a little bit about what we do at TruSTAR, but I'll go into more about the problem space that we are trying to address. Want to talk a little bit about the solution requirements as we thought through why graph databases are a good fit for the problem we are trying to solve. And then Ian will be talking about our technical approach and also showing a case study with real-life data that we received on our platform that highlights how using a graph database was effective in understanding patterns very quickly. So let me spend a little time talking about the problem space itself. So if you have been following the cybersecurity field for the last few years, you will have noticed an uptick in the number of incidents, security incidents, that have started percolating into the mainstream consciousness. Right? It's a few years ago, it was all about advanced persistent threats that were trying to conduct espionage, very, very specific kinds of attacks. But over the last couple of years, we have started seeing a lot of these attacks become more sophisticated as the defensive mechanisms have also gotten more sophisticated. And if you're not familiar with the Verizon data breach incident reports, I would highly recommend picking up the ones that have been published in the last couple of years. This is a report that Verizon publishes every year. And in 2015, one of their conclusions and one of the trends that they pointed out was attacks are spreading from one company to the next in a matter of hours. And in about 75% of enterprise attacks, they spread from the first company to the next within a matter of 24 hours. And the median number of days that threats are present on the network is to the magnitude of about 200 days. So you're looking at almost more than half a year that these attacks stay persistent within the enterprise infrastructure. So it is clear that a lot of the attackers are using the same techniques, are recycling the same strategies for going after different companies. And this year, if you have been paying attention to the latest trend in cybersecurity, which is around ransomware attacks, that is a classic example of how attackers are coordinating among themselves and using the same kinds of strategies to go after multiple companies. If you're not familiar with ransomware attacks, the idea behind that is they will send some kind of an email that where an unsuspecting employee might click on it, it will download some kind of a malware and lock up all your infrastructure, and you have to pay them a ransom for the attackers to give you the unlock keys. Just last week, the University of Calgary ended up paying $20,000 in this kind of a ransomware attack, and FBI has also put out a number of bulletins around ransomware attacks being on the rise. So it's clear that the bad guys are sharing. The bad guys are using technologies like encryption, like collaboration, to become more effective. And so why aren't the good guys being able to use some of the same technologies and techniques among themselves to better protect themselves? And we wanted to address that specific problem about what is it that is holding the good guys back from collaborating and exchanging incidents that they are observing within their own infrastructure. What we realized was we need to close the gap between the attack speed and the sharing speed. And in the quest to address this need, we've identified that, and we are building a solution that will foster community-wide incident exchange, and it will need to do the following. First of all, the user need to be able to share data among each other anonymously. They need to be able to collaborate without their identities being compromised. The second is they need to get enrichment, and they need to get value back from the incidents that they're sharing. And this is where the power of correlation becomes extremely important. And when Ian is talking about some of the how we have used graph databases, this is the component that he'll be really focusing on, is the power of correlation. Collaboration is obviously important, but collaboration, again, needs to be done in a way that is secure, that is real time. Some of the things that have happened in the security industry over the last few years is there has been increasing level of automation, which is important, but that is not sufficient in building better defenses. The humans need to be part of the loop. So how do humans become part of the loop? And then there are things which need to bring alerts to the humans in a rapid way so they can respond accordingly, and then really make it part of your entire ecosystem. So what TruSTAR is doing is building an incident exchange and collaboration platform that allows organizations to share incidents quickly, to correlate incidents and gain insights, and then quickly collaborate around the incidents. The idea, again, being the window of opportunity for the attackers needs to be closed, needs to be reduced. And that is the core defining principle behind what we are doing. So I've talked a little bit about what TruSTAR is doing. Now I want to spend a little time talking about what is it that makes cybersecurity data and the kind of users that we are dealing with, what is it about them that makes graph databases relevant? Right, so when you think about cybersecurity data, there are certain characteristics, and there are both operational and technical implications of that data that need to be taken into account. The first one is the data itself can have a large number of relationships. Right, so a very simple example is a hostname can resolve to multiple IP addresses. Now, if you're familiar with cybersecurity, you will realize that this is how a lot of botnet detection happens. But that is part of the data, of the characteristic of the data. And when you have a large number of relationships, what needs to happen is you need to be able to identify the common patterns and interactions quickly. The second characteristic is that the data can have a lot of complex relationships. And when I say complex, this can be both in terms of semantic relationships as well as temporal relationships. Some of the relationships that cybersecurity data formed within itself can have different meanings depending on the time as well. So building on the previous example that I gave, when we talk about data with complex relationships, think about a host name that resolved to different IP addresses, but at different points in time. So what the complex relationship means is that we need to be able to determine the context of these interactions at a specific point in time. And that is extremely relevant to cybersecurity operators. The third characteristic is data can be collected from a number of sources. So right now, when you think about the kind of infrastructure tooling that goes into place in enterprises, security analysts and security solutions are looking at data being collected from firewalls, from their web application logs. They're looking at other kinds of software logs. They're looking at access logs, access control levels. When you think about the kind of sources and the data that comes in, the data model itself cannot be static. It needs to be adaptable, and it needs to be able to change easily. And then the final characteristic is the volume of data that cybersecurity operators deal with is increasing on literally a daily basis. 10 years ago, you'd be looking at cybersecurity data volume that was in the magnitude of megabytes. Today, we are looking at cybersecurity data that's in the magnitude of terabytes, right? So when we talk about the kind of processing infrastructure that needs to be put into place, it has to scale without a significant impact on performance. So those were some of the considerations that we need to keep in mind as we think about the data itself. But when we look on the other side, in terms of what do our users really want to know about the data? And again, these are just examples, high-level examples, but you can kind of break them down into three categories: tactical, operational, and strategic. When we think about the kind of tactical details that our users want to identify, think about the ability to understand incident activity that is currently being observed and investigated, right? The idea here being that if I am a security analyst, I want to try and enrich the malicious indicators that I have just observed. These malicious indicators could have been provided by my intrusion detection system, by my firewall, and I want to correlate this against other known activity. This is extremely tactical in nature. The idea being, what can I do about this incident that I'm observing right now? The second type of question, which is a little bit more operational, is trying to understand the techniques and procedures that are being used by the attacker again and again. So are there common exploit patterns that are apparent among all the observed incidents? And if I'm looking at it from a security operations manager perspective, the last thing I want to do is to keep on putting out the same fire again and again and again. From an operational perspective, I want to understand, why am I getting attacked again and again using the same vector, and what can I do to prevent it from happening in the future? This essentially allows me to focus more on the strategic side of things, which is the next level of detail that our users are trying to find out, which is, how can I get ahead of the threat curve? What can I do in terms of putting mitigation actions proactively into place so that new attacks are detected as soon as they happen? Think of this as taking preventative action. Now, all of these, the tactical, operational, and the strategic, can be done in a silo. You can do it, but it's not as effective. What we are trying to do at TruSTAR is to bring together the ability to take tactical, operational, and strategic decisions as a community. The notion being that you can raise your level by looking at an action by yourself to a higher level and take coordinated preventative action as a community. Right, so as we think about the data model considerations, and as we think about what kind of relations our users are trying to identify, it became clear to us that a graph database was going to be the way to go. At the beginning of the presentation, Stefan talked about the advantages and some of the differences between traditional databases and graph databases. Knowing that we were going to be driven by the requirements of, we needed a data model that could define complex relationships. We needed a data model that allowed itself, that lended itself to being asked very pattern-specific questions. And we needed a data model that allowed us to develop context around relationships. And these are requirements and characteristics that lend itself really well to graph databases. And again, just to kind of give you a very high-level sense of how TruSTAR looks at cybersecurity data and how it implements the graph database within its workflow. Imagine there's a security analyst who has seen an incident. They submit an incident report to the TruSTAR system. The system then automatically extracts what we call indicators of compromise, or indicators which are relevant to that particular incident. And we create, within our data model, we map the specific incident to our ontology. And our ontology right now is built on being able to link incident reports to these different observables and these indicators. And at a very high level, the next step is to be able to correlate and see how these linkages connect with other reports within the TruSTAR system. So keep that in mind as we go through the next few slides, and as Ian talks about the graph database and some of the visual aspects that we have been working on. And with that, I'm going to hand it off to Ian.
Thank you, Shimon. So I'm going to be talking a bit more about our approach to how we tried to solve some of these problems and show you guys the product and some cool looking graphs in the process that we're pretty excited about. So the core to our approach has been one of enrichment and discovery. And as TruSTAR, we want to sit in the cross-section of both of those because we believe that is the the way we can best empower our users currently. So, in lieu of a bunch of slides, I am just going to go ahead and jump into our product, because then I can show you exactly what I'm talking about with these methods of enrichment and discovery. So let's jump over to, I'm going to go ahead and log into our system. And I'll jump into a report here. Cool. So right here we have one of the reports in the TruSTAR system. And let's first talk about enrichment. The way that we had been doing enrichment in the past was twofold. One, we would extract indicators from reports. And for everyone viewing the webinar right now, you can see that we have a report here. It's a fairly short report, but all of the indicators that we've found in this report have been extracted and are shown in blue. And we let our users export these in a number of formats. And we do this because we believe it's very important to use the technology we have to take these indicators out and give them to the user. But at the same time, we wanted to take this a step further. We recognize that handing these indicators to our users, while helpful, also doesn't give any context into each of these individual indicators. And that's something we really wanted to do. And that's part of what helped inform our decision to go with the graph database. Another thing we're doing here is we take these indicators and we correlate this report with a number of other reports in our system. And right now, what we've been doing in the past, we would give a list to our users of any reports or indicators that correlated with the one we were viewing. And users can click through these and view some enrichment with VirusTotal or Facebook Threat Exchange or other platforms that we're using. But again, it felt like we could go further. It felt like we could enhance this feature even more, because let's say you're looking at a list of things that correlate with this report. An obvious question, if I'm an operator, might be, how do these relate? I want to very intuitively grasp how these two reports are connected. Just knowing that they share a number of indicators doesn't provide me with the level of information I would like to better be empowered. So next, I'll also talk about discovery before getting into how we approach solving these problems. So for discovery, we have of course search. We let, if you have a term, or let's say you have an IP address, any indicator that you want to search on, you can certainly do that in our system. But the limitation with search, of course, is that you need a search term to go off of. If you want to do free-form discovery, and if we want to let our users do free-form discovery, we don't want them to be limited by first having to know what they want to search for. When you input a report into the system, that can essentially be your search. Another thing we do is allow, we've shown how all these in blue are extracted indicators. And so these are exportable and such, but you can also pivot on these. So if I want to get a better view of every report that contains a certain IP address, I can click it and I can drill down and go deeper. And while helpful, again, this is more limited in that it only allows going one level deep at a time. While you can drill down deeper, of course, it then doesn't let you see where you came from. We wanted to further empower our users by letting them go deep and do very in-depth discovery, while also letting them see how they got there. And so all of these together really informed our decision to use a graph. And when I say graph, I mean the data structure, not necessarily a graph database, but of course, that was the next step. And so Neo4j proved to be an extremely effective solution in letting us build out a graph representation of our data. So in the case of this report here, I'll just quickly open up this graph while I talk a bit about it. We can see the same relationships that we had throughout our system, but they're modeled in a much more user-friendly and intuitive way. For instance, the one other report that connects to this report that we were looking at we can see it's connected by this single IP address. We know exactly how they relate, and we know the degrees of separation that separate these two reports. We can also see that that this report has these other indicators, but that they don't lead necessarily to any other report in the system. This is all information that's not necessarily intuitively available to the user if they're looking at a list. And so for our case study, I want to show an example of, well, before I get into the case study, actually, I'll briefly talk about the technical considerations that went into all this, because this is all very fun, and we've had a great time building this out, but it was certainly not done entirely by us. The database backing this, of course, is Neo4j, and it gave us a very, see, here's a more complex example. It made this very intuitive for us as developers because all the data was already modeled for us as a graph. So when we get it out of the database, we simply render it to screen. We don't have to do a lot of complex data parsing. For instance, if we were using a relational database, we don't have to manually connect all of our nodes and build our edges to form a nice graph data structure. It's done for us by Neo4j, which has been really helpful. And in terms of the visualization, also, it would be great to take credit for all this and say we just, whip this up in one giant SVG, but we've got a lot of help from D3, which has been a lot of fun to work with, and essentially we've been building on top of the work of some really excellent technical products, which for me has been a ton of fun. My background is a bit on the back end, but a lot more on the front end, and working with these visualization technologies has been just excellent. The initial prototype of this was built out in about a week because the technologies we're using are so fun and intuitive to work with. Okay, I'm going to jump into our case study, get logged in, and find the link. Okay, so for everyone watching, this is a report that came into our system on March 21st of this year. And this report details a ZEMU exploit scan on this IP address that is not an IP address of a member of the TruSTAR community. And so if we start out by looking through this report and we see all these indicators that have been extracted. It's a mid-sized report, and we want to know more. We want to view some enrichment for this report. So we would open up the constellation, the graph feature that we've been talking about, and let's give that a look. So again, as opposed to working with lists, we now have this much more intuitive graphical representation of what's going on here. Let's look at the initial report is in dark blue with the TruSTAR logo on it here. So the title, as you can see, is talking about this 158 IP address, and here's that IP as an indicator. We see that this IP connects us to a whole slew of other reports in our system. Most notably, we see, let's check out this report, for instance. Open up to check out what's going on in this new botnet node, and we can view the contents here. And what we might discover if we read through this is that our initial IP address, this 158 IP address, is also found here in this list of this IP bot list. And what we can do with this information now is we see that this IP address has connected us to this whole list of other IP addresses, which we can then take and plug into whatever system we're using. And this all happened very quickly because, as opposed to simply scanning through disparate reports in the system, we were able to make a quick jump from our IP address to another connected report. Close that out. Okay, going to jump back into the presentation here. So, in summary, this is incident exchange and enrichment, discovery. These are all challenges that we are having a really exciting time working on, and we're continuing to work on. We've shown that the graph database has been an extremely good fit for our model here. It really well represents the form of our data in our system, but it also enables us and empowers us to build better visualization tools for our users. As Shimon talked about, we are certainly not in the business of removing the security operator from the loop. We recognize the power of having a human in the loop working on this incident response, and we want to empower that user. And we also talked about how we're using Neo4j to address all these challenges. And in a future follow-up, we may discuss more how we model our data on the back end and the way we build these interrelations. But here we wanted to focus more on the interface and how we're connecting our users as humans to our data. So for resources that we would love to point anyone who's interested to, the Neo4j user community is excellent. It is one of the big reasons we chose Neo4j. In fact, I myself went to a meetup here in San Francisco and met some of the members of the team. They were all extremely supportive, extremely helpful, and we got set up with Neo4j the next week and have had a great experience ever since. You can also check out our blog. We love to write about all our technical challenges, our challenges in the security space. You can find all our posts, both technical and non-technical, on there. The visualization library, as I mentioned, is D3, and there are a slew of excellent examples online showing how you can build things a lot like what we built, which is a force layout, which is essentially a physics simulation in your browser that allows you to visualize graphs, such as those graphs that Neo4j is modeling on your back end.
And yeah, definitely one of the things that has been really helpful in us being able to show the right kind of insights is how easy it was for us to model our ontology using the graph database that Neo4j has put out in the market. And going forward, there's a lot more that's happening in terms of the analytics that we are running on the graph database, and obviously as we go forward and we explore how to gather even further insights into the data, we would if you have any questions around those, what is happening on the back end, we'd be more than happy to answer any questions. You can reach out to either Ian or myself. And if you're interested in learning about TruSTAR and how we are helping the incident exchange and collaboration between enterprises, please don't hesitate to reach out. We'd love to have a chat with you. So with that, I would like to thank everyone for taking the time to listen to us and go through the presentation. And I believe now we'll be opening it up for any questions. So Stefan and Corey, back to you.
Yeah, thank you, Ian. Thank you, Shimon. Great, absolutely awesome presentation. I saw we got 2 questions so far. First question, does TruSTAR have much concern over attackers attempting to counter your anonymous collaborate incident sharing process by injecting misinformation into it? If so, is Graph leveraged to detect this?
Yes, that is always a very big concern, and that is a great question. One of the things that keeps us up at night, or definitely kept us up at night, was what what kind of mechanisms can be put into place to identify if there's misinformation or if there's bad information being injected. And this is where graph analytics have been supremely helpful. On the back end, we are constantly running analytics, things like centrality detection, to determine if a certain cluster of reports look a little, what I would say, abnormal. And we're always in the process of detecting these things that look a little odd, that look abnormal. So again, being able to use the graph database on the back end allows us to do this in real time and do it really, really fast. A great question.
Awesome. Another question coming in, what tools do you use to visualize the graph or the web client?
So I'll handle that question. I'm not entirely sure what the question is referring to, but if you're talking about the libraries we use, our entire web client is built in JavaScript, and we use D3 for the physics simulation that allows you to drag nodes around and reposition nodes and do all that fun stuff. And then overall, the larger system and how we manage state within the app is all handled with React and Flux. So if that's what was being referred to, then I hope that answers your question. But also, feel free to reach out to me if you're curious. I'd love to talk about this stuff. And in general, D3 is the answer to how we're doing most of our visualization on the front end.
Awesome. Thank you. Thank you. So there are no more questions, I see. So with that, I would like to wrap up our webinar for today. And thank you, Ian, and thank you, Shimon, as well as the audience out there for your attendance. And I wish you all a wonderful day or evening. Thank you and goodbye. See you soon.